Hi everyone, welcome to this session about consumer-driven contract. And well, we will be talking about one of the projects under the Spring Cloud umbrella, which is a Spring Cloud contract. Has anyone heard about the project? Raise your hand. Okay, well, today I am very glad to speak with Olga. So Olga, can you introduce yourself?
Hello, my name is Olga Maciaszek-Sharma. I have just recently joined the Spring Cloud team in Pivotal. However, I have been contributing to the Spring Cloud contract project for a few years now. And here's my Twitter handle if you want to contact me.
Well, my name is Eddu Melendez. I am a software engineer and open source contributor. I am from Peru, so yeah, I am Eddu from Peru. And well, looks like I have a preference to contribute to Spring projects too. So that's my Twitter handle. You can find me on there. Okay, it's 2018, so the rise of adoption in microservices is very big. But first, let's recall how the software architecture evolution has been. So first we had the spaghetti-oriented architecture, which, well, the lack of a structure, our application, there was a lack of structure in the application. Well, basically developers at the time used to copy and paste code from another pieces of applications. That's what we call at the time reuse code, right? And then we built lasagna-oriented architecture, in which we started building modules. We started reusing code, but in the right way, thanks to the modularization. Then the ravioli-oriented architecture, right? Which AKA is microservices, and it's where we are right now at this time. Basically, we are trying to build loosely coupled applications, but in the right way. So the monolith, which we are very familiar, I think, basically is a box where you can find your code, the service, the front end, everything is in one box. And the validation for the front end for the web application that we are exposing, it's in one place. Okay, and the only thing that we need to do is render this HTML in the browser. And then the time goes, and we divide it, or we split it into a service and a web, but this is still a monolith. In the service we had all the code that is rendering, is exposing the JSON or XML. The problem here, or maybe not the problem, is we have to deal with some validation, for example. So we had to add validations in the service and in the web application too. But since we are moving to the microservice architecture, we don't have just one consumer. We have a lot of consumers right now. And it's not just a web application. There is also Android devices that are consuming services, iOS, or well, mobile devices in general. Also, there is cars, fridge, the IoT thing, it's increasing and consuming services. Everything is a service right now. So in the microservice architecture, what we are trying to do is build a service which is just in charge of one thing. And this service should do this thing very well. One of the quotes that we have here, it's organizations which design systems are constrained to produce designs which are copies of the communication structure of this organization, which was said by Conway. which turned into a Conway law. I am pretty sure you have heard about it. And one of the words that I would like to highlight here is the communication, because it's not only communication between systems or services, it's communication in the team, inside the organization. Development teams should be speaking all the time in order to build a great product, a great service. And let's talk about the Agile Manifesto. One thing that this manifesto is people and interactions over process and tools. And people and interactions is, well, communication. They should work together. So that's one thing that we are going to talk here. Microservices. Well, as I said, 2018, everyone wants to move to microservice architecture because there are many of benefits, or at least that's what the theory said. Theoretically, it should work fine. So we used to have a big ball of mud, and then we decided to move to microservices because working on one thing, it's easy because I can set up my service fast. I can build one thing very fast, and I should just worry about the communication between the other services, right? So, who have heard that building microservices is easy? Okay, there are some things that we need to address in order to move to microservices, and we need to address it before, not during the microservices development. We need to think about the deployment, which is the deployment strategy that we want to address, canary deployment, blue-green deployment, in order to avoid the downtime of our service. No? So today, big companies like Netflix, Google, they are deploying services every minute, and they don't have a downtime. APIs, we need to build properly APIs in order to expose to our consumers like any device out there or another third-party services. Contracts, we need to address how are we communicate with the other services that we are integrating with. Testing, so testing should be easy in microservices, right? Because since the microservices is in charge of one thing, the testing should be easy. But it's not, and we are going to figure it out later how to address this with the project, with the Spring Cloud Contract project. And there is another topics which I am pretty sure you have heard about it, like the service discovery, health checking, configuration, circuit breaking, and observability in general with tracing, logging, monitoring. And there are many sessions during the conference where we can hear about it, and it has been covered in previous conferences too. So the two topics that we are going to cover during the presentation is about contracts and testing. Because why we have chosen these topics? Because there are some pains during development that we need to address, we need to achieve that in some way. When we are developing services in general, we have some issues, like I want to test my service against the other service A against service B. I cannot do it because maybe the development environment is unstable. Well, the service is not available for any reason. So maybe the development team from the service B is deploying the application. So there is a downtime there which affect my development. Or maybe I want to run some scenarios. I want to test some scenarios, and I don't have the data available through the service. Or maybe there is another service which is down, like a third-party service or something like that. So also, if I am not writing tests, the only way to test it is manually. So we can find tests, or we can find bugs during the functional test, which is not so cool, since it involves a lot of time doing it.
So as Eddu has said, there are a lot of different challenges pertinent to microservice architecture. And one of them is testing. And I'm going to talk more about testing because it's very related to Spring Cloud Contract and contracts in general. So this is the testing pyramid. It's not anything new. It's been with us for a while. So we've known for a long time that we should have a lot of unit tests, a bit less integration tests, and then only some end-to-end tests. However, with monolithic architectures, we have seen people still heavily rely on end-to-end tests. And we have seen pipelines with a testing stage that took ages. And then usually these tests would fail at the end, and then a lot of times they would fail not because we had bugs, but because the environment was not reliable. However, people were used to relying on that, and in monoliths, it somehow worked. However, when we talk about microservices, it's not anymore possible. Why? Because we don't have anymore one app deployed there. This app has to communicate with many other services to retrieve data. And even if an environment with one app was sort of flaky and unstable, now if we have many apps, it becomes so much worse. Because let's imagine this. If we have a test environment and we have an app A that we are testing, and then this app has to communicate with many different services. And probably, since we are working in a microservice infrastructure, there are many teams contributing to those services, developing them actively, pushing the changes. So the apps are being redeployed, the apps are being changed. Now, in production, we would usually have 0 downtime deployments. But in test environments, usually not. So it becomes incredibly unstable. Now, the one approach that we could take is to have an environment per service. So let's say I have my service A, I have a pipeline for this, and then I have a testing environment for that service A where I deploy all the other collaborators. So that's in theory possible, but if we look at it, it's extremely costly. Not only when it comes to infrastructure, but especially when it comes to maintenance. The other option is to have one test environment and many pipelines. So we have different pipelines for different applications, but they all sort of test on the same end-to-end environment. But then, as we've said before, they're incredibly unstable. And then there's another topic, which is deployment coupling. So as we move to microservices, we divide our code, we move it to different repositories, we make these nice small applications centered around bounded contexts. We have smaller teams developing them and maintaining them to make it faster and easier. But if we do rely on a lot of end-to-end tests running on a single environment and all the other collaborators deployed there, then we end up with deployment coupling. So our code base is decoupled, our teams are decoupled, but our deployments are coupled. We cannot independently and fast deploy any single service. And in this way, even though we have divided our code and we are working on smaller functionalities, we cannot leverage fully what microservices have to offer. Another issue which we have is the fail-safe versus safe-to-fail approach. So before, the approach was, I think many of you might remember that, we had those very long manual tests, a lot of end-to-end tests. We had code freezes, all in an attempt to make our application fail-proof, to just ensure it has no bugs. And it's a nice dream. It's a nice thing that if we could have it. However, the research shows that even the best tests will never fully cover the applications. There will always be bugs. And now with the complexity and with the scale that we have in microservices, it wouldn't work at all. So we would go for the other approach, which is safe to fail. We accept that our application will probably fail, but we need to be able to address the failure very fast. So we have addressed it on the code levels. We have small repos. We have small teams. It's easy for us to find bugs and fix them. Also, we try to deploy regularly, have continuous integration, continuous deployment. So there is less changes that we have to go through in order to find the missing point or the problem. And then what we also need is to be able to deploy it really fast. So we want to be able to deploy it in minutes from merging it to our code base. And that's why also, again, end-to-end tests have to be greatly reduced. We only want to use the most critical scenarios for end-to-end tests. In some cases, some companies would not use them at all for microservices. Another thing to keep in mind while testing is circuit breakers. So as we know, while using HTTP communication, it's a good practice to have circuit breakers. So to have a mechanism in place to ensure that we are not keeping on sending requests to applications that are not responsive and only making them worse. However, any good circuit breaker would usually have a fallback. So whatever we are using, we can be using Hystrix, Resilience 4J. We have to think of a fallback. What should happen if we cannot continue sending requests to our collaborator? And in the end-to-end test, what can happen is that instead of testing the actual behavior of our application, we will be testing fallbacks without realizing it. Of course, it can be architected away, and the test can take it into account, but it's yet another issue that we have and yet another reason to try to not rely on end-to-end tests. So what is an answer to this? We don't want to run many end-to-end tests, only critical scenarios, or maybe none, that depending on the company. What can we do to still somehow test the integrations and test our functionality? We can use stubs, and there are many tools that provide stubbing. For example, for REST, there is WireMock, which is an in-memory HTTP server that will serve a response matching a request. So we can write a JSON, say, this is my request. If you get this request, give me that response. And there are also other tools for that. Eddu will talk more about them and show some code examples. And same with messaging. There are a lot of tools that allow us to sort of stub messaging routes for our tests. There is one big problem with this. In all these approaches, it's the consumer of the API, so the application that either sends requests to an API or listens to messages, that controls the stubbing process. So the team that is developing the consumer also creates the stubs. So let's say the team A wants to send requests to team B application, wants to send a GET, and they have gone to coffee, they have talked about it, and they have decided to do GETs at URL at endpoint X. And they have even written an email about it, yeah? So now the consumer team is happy. They can go, they can write the stubs and use WireMock or some other tool, and they will be sending requests in their test at the endpoint X URL and will be getting responses with status 200. And that will work because they have written the stub. There is no way it will not work. However, the problem can occur when we go with this to production or maybe, hopefully, earlier to some test environment. And it appears that the team Y has changed their mind, and they prefer to have endpoint Y. However, they have not told us about it, or they have forgotten, or they just got it wrong from the beginning. We rely on human communication to control our APIs and to make stubs. And stubs are now our main point of ensuring that our integration works. So that's bad. The same thing can happen with messaging. Again, it's the consumer application that stubs messaging process for their integration tests. And again, they can set up any framework that allows stubbing messaging to listen, to send messages to topic foo with a product, which will have fields product ID and product name, because that's what they have agreed on, and the test will pass. But once they integrate it, it can appear that the other team has implemented it wrong and it's sending the messages to a different topic, or what actually happens a lot, the field is slightly different, like we see in this example. So we thought we were getting product ID, but we are getting ID. It's a small change, but we will not be able to deserialize it. So that's the problem with stubs. And another problem is stubs get rusty, because even if we got it right in the beginning, there is a possibility that the other team will start changing things in the API. And this might not be the best practice, but it still happens. Probably many of you have had this experience if you have been integrating with an external API provider, public API provider, credit card payment provider, or maybe accounting service provider, and they give you documentation. They send you an email. That's how our API works. So you implement it all in keeping. You're happy with yourself. And then you test it, and nothing works. Because even in the public APIs, which are supposed to be very much by the book and very well described, very often there appear changes that people forget to document and nothing works. And it happens so much more when we are talking about a microservice environment within one company. So the stubs get rusty. And what we want to show you today and do some demos with it is a consumer-driven contract approach and exactly the Spring Cloud contract implementation, which is trying to solve this problem. So we want to use stubs, but we want to test before that our producer is doing exactly what the stubs are showing, or rather the opposite. We want to test that our stubs reflect the producer, and we want to make sure that the stubs will be updated if anything happens to change with the producer. They shouldn't change things, but they still might, and we need a way of knowing that they have.
Okay, consumer-driven contracts. Well, as we said at the beginning of the presentation, we mentioned the Agile Manifesto, and we also said that the communication matters. So nowadays, there is a team which is in charge to build the service. There is another team which is build the web application, and another team for the mobile application. So they agreed to build a contract, the communication between the service and the consumers. And the service is built by the providers. And this service, it contains, in the first time, it will contain a lot of information, which may is not used by the consumers. Because every application, it behaves in its own way. So what consumer-driven contracts enable is to, consumers will help to the service providers, to the providers to ask about the right scenarios, the right information that they need. So some terminology that we have been talking during the presentation is about the producer, which is the service that is returning the data. The consumer, which can be the web application or the mobile application, and the contract itself, which is the agreement between the producer and the consumer. So we have talked about, we are going to talk about the Spring Cloud contract. So there are some benefits to use this project. From the producer side, it has a nice DSL to define the contracts. It is based on Groovy. It will also generate stubs out of the box, generate tests against defined contracts. And there is also benefits for the consumer side, because the consumer will be validating the request against the contracts, and it will be running the stubs auto-generated thanks to a stub runner, which is provided by the framework itself. So if you're familiar with the Spring framework, maybe you have been using the mock REST service server. which in Spring Boot is more easily to use thanks to the REST client test annotation. So we will see it later during the demo. And if you are using Wiremock and started using Spring Cloud Contract, maybe you have used the auto-configure Wiremock annotation, and your test looks like this. So let's see some code. Okay. First, let me show you this test. Okay, this is using the mock REST service server and the web client. So basically, it will be injected by the mock REST service itself, and I am calling here I am writing here what the service expects. So I am calling a product service, and I will return a list of products. So, and using Wiremock is just like we see in the slides. I will configure the port for the auto-configure Wiremock, and I am writing a stat for that. But as Olga mentioned, it can be outdated. This is in my consumer side, so there is nothing which is in charge of validate the contracts against the service. So this demo will be based in a shop application. So basically, we have a shop, a shop service, a warehouse service which will return the products to display in the shop. There is also a module for payments, which is will communicate with the shop in order to make a purchase in the application. So I will start with the producer first. I'm sorry. Okay. This is a classic Spring Boot application. The only thing that is new here is this dependency. So the Spring Cloud Starter Contract Verifier, which we will need to write the contract. We also have to make sure that we have the dependency management. Okay. And I am using the Flinky release. And also in the plugin section, we should have the Spring Cloud Contract Maven plugin. And make sure that the extensions is declared. Okay, and forget about this section. I will not explain this right now. So we said that Spring Cloud Contract provides a nice DSL. So this DSL should be inside of the contracts in the source test resources directory. The contract itself, it says, okay, let's make a request. The method is get. The URL, it will be products. And the headers for this request are a content type, which the value application JSON UTF-8. And the response is, or should return 200. Well, the same header is expected. And here I am telling the service that the body that will return, it will be a list of products. Okay? So this is, I think, it is very readable. So everyone in the team can read it without having issues. So once we have this contract, we can start building the service for the producer side. And we can also share this contract with the consumers. So as we said, there is a product endpoint, which I will write just right here. So this is a classic controller in Spring, a REST controller which has a product endpoint, and it is consuming a product service, which doesn't do anything for now. Okay. Well, once I have write the service, I am moving to this part, to the configuration, because my service or my test will don't know about the service dependency that the controller already has. So what we should do here is telling that all the tests auto-generated by the Spring Cloud contract are going to use or to extend this base contract test class, which is right here. So what we are doing here is telling to the service, to the controller, that we are going to inject a product service with these mocks. And if you have seen, this information is the same that we already built in the contract. Okay. One thing I forgot to mention is about this special syntax. We can say to the body or that we are expecting an ID between 0 and 9, and the size or the length of this ID should be between 1 and 10. Okay, so the only thing that I did is just mocking the service. I am not writing anything. So I will be just right here. And thanks to a Spring Cloud contract, we will be getting a stubs. This is a new artifact that is produced by a Spring Cloud contract. If you are running a classic project, you just have the jar and the POM. But here it is created a new jar with a classifier stubs. So, but a Spring Cloud contract does even more. Do you remember the test that the contract that we already write? There is a test which is auto-generated by a Spring Cloud contract, as we said, and it's extending a base contract test because it's what we said in the POM file. Okay, every test should extend the base contract test. And basically, what we have here is using Spring Cloud contract is using rest assured, sorry. Here is the request that we write in the contract. A content type, expecting application JSON, calling to a products endpoint, and expecting a 200 status code, the content type, and the response that we already defined. So Spring Cloud contract is who produced this test. I have not written it, so this is one of the benefits. Producers should write just the contract. And yeah. So from the consumer side, once we have installed the project, the stubs, sorry, I was forgetting this. During the installation process, we have some mappings. This is a JSON configuration for Wiremock. As Olga mentioned, Spring Cloud contract uses Wiremock internally, and this is the file configuration for that. So basically, it's another structure, but this is auto-generated by Spring Cloud contract too. Basically, it's what my Wiremock does is read this configuration, and it will be match the request that we do against the service, against the request section, if it match, it will return the response section. So this is in a stubs folder inside the target, and this is what is installed when we did the Maven clean install. So from the shop, from the consumer side, the testing is quite simple, to be honest. What we should do here is just add an annotation for my test, which said auto-configure stub runner, the ID for the project. This is the coordinates from the Maven project, which is com.example, SCC, warehouse. This plus sign, it means that we will be using the latest version installed in the process, in the project. And this is the port where the stubs will be running, okay? And there is some additional configuration, the stubs mode, because you can do it in 3 ways, okay? You can use local if you are installing your stubs in the Maven repository, in the M2 folder. You can also have the contracts and the stubs inside your consumer application, but you can, but not sure if you should. And there is also a remote option which will communicate with the repository manager. It can be Nexus, it can be Artifactory. So if you are using the remote option, then you can, and if you are continuously delivering your producer or the contracts and the stuff for your producer, you will be always testing against the latest changes that the team has delivered. So my test is just calling the service, which is a dashboard. What the dashboard controller does is there is a REST call to the warehouse URL. Well, basically, if it doesn't have products, it will be return no content status, and if it has products, it will return 200 with the body. So we are not doing a mocking here or stubbing. I am not writing anything. Just added the auto-configure stub runner, so the stubs from the warehouse will be running under the port 8080. So let's run the test. And as you can see, it passed. And this is the match in. This is the log from Wiremock. It says, okay, it matched. Okay, but everything is success here, so let's see. Okay, so you can see here the logs. Wiremock is running, and it's okay. It will call a get from products, because that's the call that the dashboard controller is doing. I am doing a get to the products service. Yep. So now Olga is going to talk about messaging integration.
Is it on? Yeah. Okay. So we have a payment app. And this is an app that will have some business logic for processing payments. It's not important from the point of view of contracts or the integration what that logic is. What we will want to ensure is that our messages are according to the contract, so that the POJO we are using for serialization and deserialization is right, and that we are using the right destinations. So we have this payment producer. which uses Spring Cloud Stream underneath, and it will simply send a payment response message with a UUID and a payment status. And then again, payment status can be success or failure. And this is the behavior that we want to have. So we have prepared some contracts to test it and also to ensure it can be used on consumer side. So first contract is for a failure scenario. So we have a label. The label will be later used by consumer tests. So that's why we are adding it here. And it will be used to find the right stubbing description from our artifact jar. So here we assume that if make failing payment method is triggered, then our app should send a message to destination payments with some specific headers and with a status failure. What is nice about this DSL is that the IDE, IntelliJ, will actually provide code completion for you. So you can write it this way. If you don't like Groovy for whichever reason, you can also use YAML. And it will look very similar. So we also have another one, which is a contract for the success scenario. It's virtually the same, but when the make successful payment is triggered, we expect our app to send a message with status success. And these methods are within the internal business logic of our application. They're not important to us at this point, because right now what we want to test and ensure is the integration and the right formats and the right topics. So let's go back to this, and let's get terminal. So I'm going to check out a version that doesn't have the implementation yet. Okay, it's not there. And we have the contract. So what will happen if we run it now? Sorry, I'm not a Mac user. It has a very different layout. However, we are running this, and let's see what happens. So we see there is a contract verifier test running, but if we go to our tests, we have never added such test. Why? So the contract verifier test that has actually failed, which we'll see here, has been added for us automatically by consumer Spring Cloud contract. Why is that so important? Because as we see, we have a contract and we need to fulfill it. We cannot build our application, and so also in a pipeline, we cannot push it to our artifact repository if we are not fulfilling the contract. So the other side that will use our stubbed routes, same as Eddu has shown with HTTP, can be confident that the producer application is actually doing what is defined in the contract. So let's see the test now. So same as with the HTTP version, this is a test that has been automatically generated for us. We have not added this test. And that's very important, first of all, because we don't want to do it, because it's tedious. And second, because it will not allow us to miss something. If it's in the contract, it has to be there. So the test uses underneath the contract verifier messaging, which will verify that when we trigger a make failing payment method, same as described in the contract, we will be able to receive a message to destination payments. And everything will be verified for us out of the box. So if we have specified some headers, we will check that they're there, and we will check that they have the right content. So, same, all the fields of our project will be tested. So we will not have a situation where we have forgotten something, where we are retaining status failed instead of failure, and it's still passing. Everything will be verified for us. So let's go back to an actual implementation. And let's so it's there, and we expect the test to pass. So now if we run, let's try and run install. Okay, our implementation is here. The test is passing. So the other test, other thing that we have in generated sources, okay, will be the stub descriptors. Where are they? Okay, so it's actually configurable where you will get the descriptors. And here, if we saw in the HTTP version, what we had was an actual JSON descriptor that WireMock will use underneath. So that was converted from the contract to the JSON. Here we get contract again because it will be used underneath to stop the messaging routes for us. And what has happened is, as we ran Maven install, these stubs were also installed in our local Maven repository. So let's check if we have them. It was at com, example, SCC, payment, and then we had a version. So as we see here, we have our jar, that's our app, but we also have a stubs jar. And now we are doing it locally, but what is important is that, again, in production, when we use a pipeline and we deploy our artifact to an artifact repository, they will go together. We will have a new version of the application, which means we will have new stubs. So whichever consumer is using our stubs, they will know about it, and they will see if anything changes. It shouldn't change because we don't want to have backwards compatible change, but they will have a way of knowing. And also, whenever they test, they will know that they're downloading the stubs that have been deployed there with the actual jar. So they reflect its behavior. They are not written by them. So let's see the consumer. So that's the shop. That's the same application we were using before. However, it has a payment part. OK, so we have a payment processor. And this processor, again, using Spring Cloud Stream. In this demo, we are using Rabbit, but it can be any other implementation. And is listening to messages with payment result. And depending on this payment result, will trigger different business logic when the payment is successful and when it's not. So we also have some tests to verify it. And these are in Spock, because you can use it with whatever framework you like. And again, we are using the same auto-configure stub runner annotation, the mode local, which in a normal flow we would switch to remote. We have the artifact ID, so it will be found by this artifact ID in the Maven repository. And then we are using the stub trigger interface that is provided for us also by Spring Cloud Contract out of the box. And it allows us to trigger a message for this label. So our descriptors will be searched through. The descriptor with this label will be taken, and then the routes will be stubbed according to that message description. And then we can verify that our business logic, or whatever logic we have for handling these results, was actually triggered for the right kind of message, so that stubs worked. Let's run it. So it all happens out of the box. We don't need to mock or stub anything with the routes. Spring Cloud Contract will do it for us. And as we have seen, the other application is not running. We are solely relying on these stubs. These stubs have been tested, so are safe. and we can use it without having to do anything because it's all been done under the hood for us. Okay, shall we go to the presentation?
Okay, so now we should be happy, right? Because we are not writing tests. We are just writing contracts, and the framework itself, it will write the test for us. Well, back to the presentation. Okay, it's yours.
Okay, so the main point is being safe that our stubs work and being able to use stubs and not collaborators. But we have some other benefits on architecture level. So as we see, as we work on these contracts, and usually the way it's done is that the consumer team would make pull requests to the producer team proposing, I would like this contract to be fulfilled. Can you implement it and provide me these endpoints and these methods in the API? And then the producer will take over this pull request and will have failing tests. We'll have to add implementation to it. And then maybe they will start passing, so we are happy with them, but then maybe we want to do some more changes. So we collaborate on modifying the contract, adding new fields, adding new methods, and then again they fail, and we implement it. So what does it look like? It's actually the very known red-green refactor pattern from test-driven development, but now instead of using it on a single class or a single component and functionality, we can use this very known and liked pattern to verify and develop and change our architecture and all our integration layer, which I think is really cool. And one other thing that Spring Cloud Contract can very easily allow us to do is checking the backwards compatibility of our APIs. So let's say we have implemented the contracts, like in the demos. The automated tests are being run, so we can know that we are in keeping with the contract, and it's all in our pipeline, of course. Then we can add an additional step to our pipeline. So once we have tested our producer app against our current contracts, what we can do is fetch the contracts that are right now in production and test against them. So what will happen then is that our API will be backwards compatible. And only when it passes, we can deploy it either to stage or some other environment. And if you're interested in adding this kind of checks to your pipelines, the Spring Cloud Pipeline project already provides scripting and that will build this kind of pipelines for you. It's very opinionated, it uses this flow, but you can, if you like this approach to having backwards compatibility tests for your API using contracts, you can have a look at it and it will make things easier. So if we have these backwards compatibility checks, and we never want to push any backwards incompatible changes to our API, which makes sense, can't we ever switch things and change fields? That wouldn't be good. Definitely, well, in public APIs, we would do versioning, and we would actually be fine with this. But in our internal microservice ecosystem, we sometimes simply want to switch things, and we don't want to keep old fields that are just there to keep us backwards compatible. But we still don't want anything to fail. So what we can do is use the same strategy that is used for database field changes, and which is deferred updates. So let's say we have a field build time in our contracts and in our producer app. It was in seconds for whatever reason, and now we want to make it right and change it to milliseconds. But we still want to be backwards compatible. So what can we do? We can first just add the new field, and we are adding it in contracts, so we also have to add it in the app. It's in both places, it's in production, it's in our contracts. Whoever was using the old field still has the old field. Now what we will do, while keeping this in production, in our repository and our working for our development process, we will remove this old field from the contract. And of course, this will only work if we are using continuous integration, continuous deployment, if people are going to download our stubs often and they will see that something has changed. But then our consumers, while developing changes, while working on their app, will see, okay, this field has been removed, we will have to remove it as well. So usually this is something that should be discussed anyway and agreed upon and not just done like this, but there is a way of automating it, so ensuring that if the human communication has failed, they will still have an automated way of knowing that something is not right and they need to adjust and start using the new field. So once a reasonable amount of time has passed and the new versions of these consumers have been deployed that can work with the new field, then only we can deploy it also deploy the producer with this new contract and have the change. Okay, so that was some things about the contracts, how they work, why they can be used, and how to leverage them in architecture. But we still want to say a bit about the current stage of the project and the future.
Okay, as we saw during the demo, we have seen the integration with HTTP and with messaging using RabbitMQ. So the current status of the project in version 2.0.1 is well, support messaging with integration with the Spring Cloud Streams, with RabbitMQ, and also with Kafka. It works with MVC, so if you already have the mock MVC test with mock MVC, you can use the WireMock DSL. There is a section in which is you can add a validation and matchers with mock MVC. There is also integration with the Spring REST docs, and you can generate you can document your stubs and your contracts too.
You can also generate contracts from REST docs without any additional effort.
Okay. There is also integration with Maven, as we can see in the demo, and there is also integration with Gradle. Spring Cloud Contract provides the right plugins for that. It also provides a stub runner. We have seen in action during the test, but we can also use it externally in another project. If you are not using Spring itself, well, you can use the JUnit rules provided by a Spring Cloud Contract, so you can get the benefits from the project. And there is also a pack support, which is one of the projects which enable consumer-driven tests. Okay, so the feature about the Spring Cloud Contract in the version 2.1, there will be a JUnit 5 extension for the Spring Cloud Contract. If you want to see the issue, you can click the link in issue 691. But currently there is a support for JUnit 5, which Olga have worked.
Yeah, so the current support that we have for JUnit 5 is same as we have for JUnit, for Spock, which is creating automatically generated tests with any of these frameworks. So if you prefer to use Spock or JUnit 5, you can have those automated tests created with them. And what we are going to add is an extension to also be able to use JUnit 5 also on the consumer side. So anyway, you can use it with the auto-configure stub runner annotation, but some people use Spring Cloud Contract even without the Spring apps, which have, apart from this, don't use the auto-configure stub runner, and they use rules. So of course in JUnit 5 we will not have rules, and we will have an extension for that. And then we are working on adding web test client support, because, well, we now have web flags, everything is going functional, and we want to keep up to date with it. So we are working on it, and it should be available pretty soon. You can also see the issue. You can also see things that we're working on under the GitHub link. So wherever there is an enhancement label, there's usually work planned for it. Okay.
I think we have some minutes to show another demo. The stub runner in action. Yep. So we have seen during the demos that we are producing, or we are running the test against the stub runner, but the stub runner is embedded inside the test. So there is another project which is a submodule from the Spring Cloud Contract, the stub runner. My Spring Boot application, it will have a dependency, which is Spring Cloud Starter Contract Stub Runner. Well, the dependency management in order to use the right version. And the only thing that we need to do here is, okay, this application, it will be a stub runner server. Okay, and now I have to define something that we have seen before in the test. The stub runner, it's in local mode, so it will be reading the artifact from the M2 folder, the Maven repository, which with these coordinates. The latest version, it will be exposing the data in the 8080 port. But the stub runner itself, it will be running in another one. Okay. Yes. I am going to run the stub runner server to see it in action. Okay, so okay, if I call to 8080, okay. I can consume stubs from 8080, and then I get a message which says, okay, you can make a GET request to products with the following content type. Okay, so I have already my script here. So if I will do a request to 8080 products with the right header, and it will be answering the products stub. So you don't have to run the application itself connecting to the database or something like that. You can run the stubs instead, and will get benefit from that. So you are avoiding some integration issues or missing scenarios for. If you are not familiar with Java, you can also use, there is a Docker image. So basically the configuration, it will be very similar. In this case, we are using the image from the version 2.0.1. Well, we will be providing the stub runner under 8083 port from the local mode, and well, the stub runner IDs that we want to run. Something that I forgot to show also is the JUnit integration, which is pretty easy.
Also, coming back to the stub runner, actually, it's also useful if you don't work with collaborators, consumers that are Java apps, but for example, you work with people that do front-end and use Ruby or whatever other technology, because just if they run one Maven command, they can download the stubs and they can raise the wire mock instance underneath, and it will be done automatically by stub runner. And as Eddu has shown, they will get these stubs and they can write requests using them. So it's also useful for other apps.
Yeah, cool. Thanks, Olga. So the only option, the only change that we have to do if we are going to migrate our test to JUnit 5 is adding this test framework option in the Maven in the POM file. Test framework JUnit 5, but also since there is no compatibility between JUnit 4 and JUnit 5, you should move, or you should change the annotation. Before the annotation it was before, and now it's before each, which is provided by JUnit Jupyter. So that will be all that should be changed. So I think.
Yeah, one more thing is that this, even though the project has been here for a few years now, it's still developing rapidly. We try to add new things, and if you use it and you have any issues, we will definitely reply to you. We will be happy to work on proposed items, and we'll be also happy to take pull requests if you want to propose some changes. So it's a project that has been developed from the beginning. It started as a community project, then was transferred to Spring, but we still like to collaborate with people from the community and have a lot of external contributors. So by all means, if you want to use it and add issues or add PRs, do it. And we will be able to show you in a slide right now some links, and you can check all the demos under the links in the presentation. And I guess we have a little time left. If anyone has a question, we can address it. Yeah? In the contract test? This one, okay. Can you show this?
Yeah, this is the contract that we already write, and let me get back to.
Okay, so also because Eddu was showing the base class, and base class is actually where you set up whatever you need for this to run, because in the contract test, you will be only testing the integration. And there are some things from the business layer that you want to stub. And you want to stub whatever you need that is not the integration layer. Because a common mistake is people trying to test business logic with contract tests. That is coupling, and that is unnecessary. We want to test if our API is in keeping on both sides. And we stub our business logic methods in the base class.
Another question? Yep. Okay.
So if I call service A, that collection endpoint, for example, but when I call from my service, I pass a filter as a query framework. Does that URI have to match exactly? So if I call from that layer, I have to go to the producer to add a contract to that?
Yeah, there are various options. You can pass query parameters also in the contract. So it has to match, but you can use regular expressions for various things that you think will change inside. For example, in the body, if you have some fields that you don't know what exactly will be, but you just want them to match a certain pattern, you have a user ID, you can use that.
Yeah, the framework itself will provide a nice DSS, so there is more options to use here, not just that one.
Okay.
Okay.
There is nothing more, then thank you very much.
Thank you, Taten.